Hello, everyone. This is a continuation of the last episode where we stood up a Nano MDM SEP Docker setup here, and we actually have that running in the background here that we'll get to in a bit. But this is a guide to enrolling a device into an MDM just via a profile that we're just going to install locally. So let's get into it. We're just going to jump to the guide here, and we're just going to follow along with the guide, and I'll explain what's happening and my process through it. So once you have your MDM service running, the next step is to enroll a device. We're going to enroll a virtual machine because it's just easier. And it's just going to enroll in Nano MDM, and then we're just going to test it out with one MDM command and then two DDM declarations. So for this guide, we're going to use Ngrok, which is like a tunneling service. So we'll just start a local tunnel so that we can have HTTPS and public access to the server temporarily, just to get everything set up easily. We're going to use Tart for a macOS VM. You could use other stuff like Virtual Buddy or UTM, but I like using Tart. And then we're going to use Data Grip. I just like this as a database like viewer and manipulator, like a database IDE. You can use something else if you want, but Data Grip seems easy enough. Then you're also going to need your MDM certificates that we made in our Creating MDM Certs guide and video that you can find on the channel. And then our running MDM and DDM service, which we did last video with the Nano MDM SEP Docker setup. And then other than those stuff, we're going to grab the enrollment config profile that's in this repo. And then we're going to want to grab Nano MDM's commander tool. This just makes sending a MDM command super easy because it formats everything for us. And all we have to do is pipe it to the endpoint on Nano MDM side. And then we're also going to use tools from KMF DDM for making the declarations and then putting it to the specific endpoints on KMF's side. So in the table of contents here, we just have a quick layout of basically what's going to happen. We're going to upload our MDM certs to Nano so that it can use it to communicate with the devices and Apple servers. And then we're going to start up our Ngrok tunnel for HTTPS. And then we're going to get our VM set up and enroll the VM, and then we'll see kind of what happens on the back end side of that enrollment, and then we'll see how to do a simple device info MDM command and a simple-ish management test DDM declaration, and that will conclude this video. So we got our server up. Now let's enroll a device. Uploading our certs. First, let's view our current database with DataGrip. So if you don't have DataGrip installed, you can just get it from JetBrains' website, download it there, and let's open it up. And you'll just get this here, and we're just going to do a new project and call it Nano MDM. There we go. We can get rid of all this crap that shows up. And then up in the top here, close. We're gonna create new data source. Data source And then we just want a regular, where is it? MySQL. This authentication info comes from our environment variable in the project setup. So if we go back to our nano MDM sub docker project files, and we grab our environment variables, I'll just show you would be grabbing this these three lines, and you're going to pop them into the boxes here. So I'll do that real quick for mine. So I grabbed my password here, popped it in there. It creates this URL string that's also defined in our Docker container. So we can kind of verify with that. And then you'll just hit apply, download the MySQL driver if you need it, and then hit OK. And then you won't see anything, but you should see a drop down here. And then we can look at our database and all the tables that we use. And so for this guide, we'll be looking at the push cert table and the enrollment table. So if I just double click on that, and let me minimize that view and drag this over, we can kind of see what the columns are here. And we'll just wait for some data to pop in there. So the next step, once we have data group configured and we just see that the push list is empty, let's cat up our MDM certs. So we're going to cat the APNS certificate that we got in the very last step of the creating MDM certs guide. And then we're going to cat up the private key that goes along with that. And then we are going to put it up to the Nano MDM V1 per cert endpoint. And so let's just copy this. So we're going to copy this command, and back in the terminal here in a enrolling device directory that's adjacent to the MDM search directory. And let's paste this in here. And we just need to change the certificate names here to, this should be push. And then this can just be, there we go. And then we hit enter, and you should get a response from the Nano MDM server with the, it's checking the validity of the certificate, the MDM certificate. This one, it's the same one that you saw in like the identity.apple portal. And then our topic is our part of the APNS push magic stuff. And we are going to need this string for the enrollment profile. And then if we want to look in the database, we can hit Command R, and that's been populated in the Nano MDM logs here, and see the server's up, and it got a put request to the push cert endpoint with curl, and it's kind of just tracing. I messed up the first time there, so I did it again, and then it spits out what it returned to us. Great. With that there, we are going to move along. There we go. We'll need the topic later, like I said, for the enrollment profile. And then we've rechecked the table in DataGrip, and our certificate was there. Next up, we need to take care of HTTPS. So the MDM protocol requires HTTPS to securely communicate with devices in Apple's MDM infrastructure. We didn't, Nano MDM has flags for doing certificates so that it terminates the TLS for you. I prefer doing like a reverse proxy in front of it that and terminating TLS that way. For this, because we're just testing it, we're just going to use Ngrok because it's pretty quick and easy. But if you want something more permanent where you don't have to change URLs all the time, because Ngrok doesn't give you the same URL every time you use it, I recommend just setting up a reverse proxy on a server that never goes down in your home lab and use like Caddy or something for Let's Encrypt certs. So for Ngrok, it uses a config file that will specify what port it needs to be tunneling. I have an example config that all you have to do is put in your auth token. So let's get that. I'm just gonna get it from here and we'll just copy it. This is what it looks like. And it just has to tunnel the SEP server and then tunnel the Nano MDM server. So let's touch a file called ngrok.yml and then let's just open it up in Vim and paste our thing in there. And then I'll be back when I paste my auth token in there. So I just signed into my Ngrok dashboard and copied my auth token and put in that spot in the config file. And then make sure I had Ngrok installed. You can just do Ngrok -8 and just shows you help for it. And so next step is doing a config check. So if we do Ngrok config check --config, because we're using a local config. Ngrok has a global one when you install it, but because for all the projects you use a different Ngrok tunnel setup, I just have a local config for each one. And you should get a valid config. And then we can just start all the tunnels that are listed in our config. So the SCEP tunnel, and then the Nano MDM tunnel, and there we go. And so we can see the temporary URLs that it gives us for our two local hosts. Ngrok also has this awesome inspect tool to see like the web traffic that's going to these. So if you open that up in another tab, it particularly helps when your enrollments are failing and you want to see what's kind of going on, because sometimes the Apple error messages aren't the most detailed, so you can kind of see what's going on. And I make a note of that here because I really do think this is cool. There's some local tools that you can use that are similar, but the Ngrok one is pretty freaking awesome. All right, so next up, we're going to finally enroll the device. Let's set up the VM. I like to use tart. It's easy and you can call from the command line. But they got bought by OpenAI, so I might move to UTM or Virtual Buddy in the near future. Once you installed Tart with their directions and downloaded a image for macOS, you can start it up. You can also follow BK's blog post about this. It's pretty nice. Just note, if you haven't used Tart and don't already have an image, they take a long time because they're pretty big. So you might consider stopping your tunnels because you are limited on the free plan of ngrok about how long and how much data goes through the tunnels. Not that the images are going through the tunnel, but just having them open for a long time works against your limit. So you might kill them, and then once the VM is up and running, you can start them again. So I'm going to do that because I need to download a fresh image for this. So I've got Tart installed here, and I cloned one of their base images for Tahoe. And then I just let it download because it's pretty big. So just to start the VM here, we'll do Tart run. I named it Tahoe base. And then this dash dir option will let us do pass like a shared folder into the VM from our host machine. So I'm going to pass in the Enrolling device project folder here, and then let that start up. And as that's going, I'm just going to copy the enroll mobile config file to our repo here. So let's do vim enroll.mobile config, and then let's just grab it here, copy that, and paste that in. And then we're going to have to change the 4 lines that are specified right here. So this is from our environment variables. When we have our ngrok tunnel set up, we just copy the URL for the set tunnel and for the nano tunnel, and then you have to copy your push cert topic that you can get from the database or the logs of your running system. So I'll do that real quick, and then I'll show you what we do in the VM once I've set that up. So I went ahead and edited our example enrollment profile here, pasted in my stuff down there too as well. We just can hide that for now. I got my tunnels running here. I got my VM running here. If I go to the VM, the Tart baked images come like auto logged in and stuff. So if we go to Finder and see my share files, we should have our ngrok, but more importantly, we have our enrollment profile here. And then we just need to double click it and install, and then go to settings and install. So let's do that. Double click this. Yes, a profile was installed. We go to settings, device management, enrollment profile, double click this. You can view all the stuff, and it'll show you like the enrollment stuff, and it'll show you more details below. And then the default password for this is just admin. And bada bing, bada boom, we've enrolled. It says it's supervised now. It's not a supervised Mac in the sense because it's hand enrolled and you can unenroll, but and then if we go here, we can see the logs that Nano does when something gets enrolled. So we see the servers are listening up here, and then it has to do the skep process to get a certificate. And then once it has that, it can go to the Nano process of enrolling. And it has this ID here. This will be important to reference this machine. This is just the unit of the machine. So if you went to system information, and then this is that same value there. You'll need that when you use Nano MDM and KMF for like referencing this individual machine to send MDM commands and DDM declarations to in the future. So additionally, we can see in the ngrok terminal here that it just gives you a little notification for all of the requests. And you can also see individual stuff in the ngrok inspect tool. So if you want to watch like the SCEP process or the MDM enrollment process, just go ahead and put that or look at that stuff as you want. All right, next up, we're gonna do some test MDM commands and DDM declarations. We'll do the device information command because it's really easy and you get some cool stuff about the device. This would be the command that we're going to use. So we're going to use a tool from NanoMDM called Commander, which is just a Python script that will format the MDM command for us, and then we just have to send it to the NanoMDM queue for that device. So in this, we have to fill in the NanoMDM API key that's in our environment file, and then the enrollment ID /UDID that I was showing in the previous clip. We're going to use the UDID to reference the device a lot, so you can just make a environment variable if you want. So I made a new folder that's going to hold all the tools that we use, like Commander, and there's tools for KMF as well. And I just called it Nano Tools, and I put Commander in there, and I just have to make it executable really quick. But in this shell, I'm also gonna export ID, and I'm just gonna go into my logs here and grab this, copy that, and paste it in there. There we go. So if we echo ID, we should get that value so that it can be referenced with the command easier. Let's just see what the device information command looks like. So literally what Commander is doing is just formatting this plist file for you, because that's what MDM commands are. And it's just going to send this raw data up to the endpoint, and then Nano processes it and reaches out to Apple, and Apple tells the device to reach out to the MDM server, and then it processes the command. So now if we do this, there we go. So we got that feedback to say that like this was successfully pushed. So after waiting for a sec, the device checks in, and we can see it here. So we sent our device information command here in this log, and then we see that the something is sent back to the server from the MDM client on the machine, and it checks, and there it is. And so if we go into our database and we go to the command results, we can see the result here is listed. I think I can make this bigger. Yeah, here we go. So just sends back another plist, basically, with some stuff about what is happening on the device. You can also see this in the ngrok inspector. Pretty cool. So that is a basic MDM command. Now we're going to test a DDM declaration. So I'm going to get the, I don't know how this is supposed to be pronounced, but I'm going to pronounce it ID color from KMF's tools. And then I'm also going to get a couple other things from KMF tools, shell scripts for easy curling stuff up to the KMF API. So I got all the tools from KMF DDM. We can see on here. There's just a bunch of bash scripts, and then the IDE color Python script is here. And so let's go through management test DDM declaration. So just to see kind of what a declaration looks like, we're going to copy this, and the Python script will just be taking in these arguments and formatting a declaration into JSON. So if I paste that in here, you should see this is essentially what is being sent up to KMF. And so we're kind of replacing the plist that MDM used, and we're doing all this JSON stuff. And then let's configure these environment variables so we can just copy and paste commands easily. And it helps using the tool shell scripts. So I think I can just doink all this stuff because I already did this ID one previously. And then let's put this at KMF DDM. The base URL is fine. Yeah, the rest of this should be good. So we have those in now. Let's clear that out. Now let's put the test declaration onto the KMF server with this. So again, it's just gonna print this out to the standard output, and then this shell script that we'll take a look at in a sec is just going to take that as input. But so we can look at what the API declaration put shell script is looking like. It's just taking our URL and putting it to the declaration endpoint for KMF, and then it's doing our user auth with our API key, and then it is doing this curl command basically, and it's going to respond back with the HTTP code that KMF gives us. So let's copy this, paste it in here, and response code 204 is good. If you don't get that, you should double check everything that you're doing. And then we can run this other shell script that it's doing very similar. If you go into KMS repo and look at all the shell scripts, they all look very similar to this. But just to see that the server has our test declaration, we can paste that, and we see our reverse domain identifier that we put here. You can do whatever you want. This is just a naming convention that KMF uses. So we made this declaration, and then KMF has these sets that link our decorations to sets of devices, kind of like how Monkey has different catalogs. So if we use the another shell script to put a decoration into a set with this one, we're going to put our com.example.test decoration into the default set, or link it together, I guess. And another 204 is good there. And then we can check that this was set properly with this. And you should be able to see all these logs in the KMF. It should say all these every time you're hitting the API, spit something out. And so like we put this decoration in here, but KMF didn't reach out to any because we don't have any enrollments that are linked to this. So nobody's getting this configuration. And so back in our other window here, continuing on. Now we have to activate our decoration. So we created the test one, but we need an activation decoration, not just a configuration one, so that it's actually applied. So again, with the IDE color tool, we're just going to make a example activation one for our com.example.test configuration decoration. And so we paste that in here. And this is basically what it's going to look like. Again, it's just regular JSON. And it has like the payload. So this could be multiple configurations that it's activating for. And then the identifier, again, is another reverse domain identifier that we set. And so with this next command, we're going to assign it to the default set in KMF. So we copy it in here. So again, we're just going to get this pasted out into standard output, and then this API declaration put shell command is just going to take that as input. So we copy that, we paste that in here, and we get another 204, and you might have been able to see stuff happen in the log behind us. So there we go. This is our activation declaration ID here, and changed is true. So they have like the declarations have state to them. So if you change something, KMF tries to be smart and knows like when something is changed, and to notify the enrollments that should be linked to that declaration. And so we put that up, and we've assigned it, and then we need to link them. So let's do that. So this is putting the activation declaration in the default set as well. So then if we go back up here and we look at the sets or the declarations that are in the default set, we should get both of them. There we go. So we have both here. And now we can assign our VM enrollment to the default set. So here we go. Another shell script tool, and then we're just feeding in the UDID of the VM and then the set name that we were assigning it to. And we pop that in there, and another 204, and you might have been able to see that was quite a bit of action here. And there we go. It gets notified every time you see the MDM client being used. That's your VM talking basically to the server. And so because the way DDM works, obviously KMF isn't doing like all the communication with the device. It's everything is like tunneled through MDM. So we have device, and it's telling There we go. So we did this to see our decorations in our default set, and then we can go through and kind of follow the path of what's happening. And so back in the guide, we can check that our decorations landed onto the device with this other shell script. And so I paste that in here, and we're just pulling this individual device, and they're just piping output to JQ, which will format the JSON for us. And so we see our decorations. We have activation decoration, which is our com.example.act. And then we didn't link any assets to these decorations in the set. So there's empty array there, and then our configuration decoration for our com.example.test. And then we didn't do any management stuff either. So we can also see what it looks like on the device. So if we look for, like, looking at this, we're seeing like everything in a broader scope. But if we want to look at individual configurations for what the device sees, we can just specify them with that. And then we can see basically what we were showing originally when we created the first decoration. And then if we want to go onto the VM, we can go into system settings and view this. So if I go to settings and I go in my enrollment profile and I scroll down, we can see device decorations, our test configuration there, and it says hello world, and it has no assets. We saw those, and it's returns to the status channel is installed. So that was a really brief intro to using Nano and KMF. Obviously, you should do some more learning because there's a lot to know about this stuff. Recommend looking at Apple's documentations to look at all the device management stuff in their repo for all the decorations. And then if you want more of a breakdown on what is happening on each individual step, Nano and KMF have their own quick start guides that I was basically referencing here, just with some more detail or breakdown. The KMF one is very detailed. Jesse goes through the process of like getting errors and how to troubleshoot that. So you should definitely check that out. All right, we will see you in the next video. Bye, guys.